I'm starting the class now. So yesterday we have discussed about the effect of temperature on different types of materials. So we have seen the expansion and contraction of solids, like in the case of, for example, the railway tracks and the bridges, because they are made up of iron. They are made up of metal. So metals usually they have a property of expansion, and when they are cooled down, they are contracted. They show a property of contraction. When the metals are heated up, they show a property of expansion. Okay, and even we have discussed about the applications of heat energy in the case of bimetallic strips. So these bimetallic strips are used in iron and fire alarm. Okay. Okay. So here in the iron, we can see the bimetallic strips, and in the fire alarm also. So what these bimetallic strips are used in? They are used as thermostats, and even we can see these thermostats in refrigerators, oven, iron, and heaters. So what happens in these bimetallic strips? When they are heated up, when they feel the hotness, when the current is passed, in the case of iron or in the case of oven, okay, what happens here when the electricity is passed, they are heated up, the bimetallic strips, they are heated up and they bend. When they are hot, they bend upward, upward or downward. When they are heated up, they bend downwards, and when they are cool, they bend upward. So these bimetallic strips, they are used in these appliances, and they are even used in fire alarms. When the strips get hot, when the fire breakout is there, when there is an accident of a fire, the strips, they get hot and they just give a caution, they give alarm, and it will be ringing till someone comes for rescue, comes for help. Okay, so here is one more example. When this hot water is poured in a glass container, so what happens to this? It gets cracked. So this happens because the hot water, outer surface of the glass, comes in contact with cold water. Okay, when hot water, usually it happens as we have discussed already in the case of a thermos. When it is in a cold condition, if you pour cold water, and soon after, if you remove the cold water and then you pour the hot water in that, then there are chances of getting cracks. Okay, and even we have seen about the effect of heat energy on liquids. Why there is a small gap in between these cool drink bottles? Because liquids expand. When the bottles are kept in the refrigerator, there might be any chances of keeping them outside. Usually shopkeepers, they keep all the cool drinks outside. So what happens here? There might not be very cool conditions in the room where they are kept. There might be hot temperature outside. So during this heat, what happens to these bottles? When they are heated, they get expanded. When they are heated, they get expanded. And when they are cool, even in the case of liquids also, when they are cool, they get contracted. So there are chances when they are getting heated up, there are chances of breaking. There are chances of breaking this cap and the liquid may come out. Okay? Because the gas is filled in this cool drink bottle. They are filled with carbon dioxide, and the gases also have a property of expansion. When they are heated up, they move upward. Okay. So even in this case also, we can see the gases, how the gases expand. When the water is boiled, the vapor comes out and it raises up. Okay. So is this clear, children? Everything for you? We already have discussed all these applications of liquids solids and gases. So we were discussing about solubility. So this is our last topic of this week 2. So here in the case of solubility, we have seen what are the conditions on which the solubility depends. Solubility depend on temperature, pressure, and pressure and the intermolecular forces. So the factors which affect the solubility here. So we are going to discuss about it. About the solubility, what is solute, what is solvent. Okay. So yesterday I think you have understood. Can anyone just tell me what is the definition of solubility or what is meant by solute and solvent? What is solute and what is solvent? Can anyone just tell me? Raise your hands. I asked you to go through this lesson yesterday after doing your homework. Have you all gone through? And for your GA, how you'll write your GA if you're not going through the lesson? Yes, just tell me the answer. No one from you? Yes. Srinika, Srihit, Harsh, Abhivir. What is solute? Abhivir, can you hear me?
Yes, ma'am.
What is solute, Abhivir?
A solute is any substance which can be either solid or liquid or gas dissolved in a solvent.
Solvent. Okay, good. Yes. Srihit. Why Srihit? Are you able to hear me, Srihit? Keep your camera. Srihit, can you tell me what is a solvent? What is a solvent? Keep your camera, everyone. Yes. Srihit, R. Srihit.
Avachalama.
R. Srihit, can you tell me what is a solvent? Are you able to hear me, Srihit? Yes, Harsh.
Ma'am, a solvent is a substance that dissolves solute.
Okay. Yes, Harsh. We are unable to hear you properly. Your voice is very low.
Ma'am, now
Yeah.
can you hear?
Yes.
Ma'am,
I can hear you.
a solvent is a substance that solute is dissolved in it, ma'am.
Okay, good. Okay, 1 second. Okay, Harsh. Yes. Good. So, can anyone just tell me? Yes, good that you're giving answers. It means that you are just going through the lesson after the all your classes finish. So please, children, have a habit of reading the lesson once again when your class is finished. When all your classes are finished, I'm not talking about only my subject, all the subjects. All the subjects you have to go through the lesson once. When the teacher is teaching, just take out time to go through the lesson. Only spend 1 hour time, do your work quickly, have a glance at the topics which are covered in your class so that it will be helpful for you to remember each and everything which you're learning in the class. And you're able to write all the small bits which are being given in your test. Okay? Yes. Now, just tell me what is meant by solubility. solubility. What is solubility? Aishwita, Aishwita, unmute yourself. Aishwita, can you hear me? Why you all are not keeping your unmuting yourself and keeping your camera? Yes, Hanvita.
Ma'am, solubility is the maximum quantity of solute which can dissolve in a quantity of solvent. It's called solubility.
Okay. So it's the maximum. Okay, good, Hanvita. It's really nice that you all are giving the answers. But what about all others? Look how they are giving the answers. They are referring the books. So solubility is the maximum amount of solute that can dissolve in a known quantity of solvent at a temperature, at a certain given temperature. It is called as solubility. So here, solute, it can be either solid, it can be either gas or liquid. Okay, it can be any of the three states. A solute can be of any of the three states, which is dissolved in the water. Solvent, water is the universal solvent. Okay, 1 second. Yes, Roman. So here in this a homogeneous mixture. Here, what is a homogeneous mixture? A homogeneous mixture is that mixture in which the solute is completely dissolved in the solvent. It is called a homogeneous mixture. We cannot see the solute. Either the solute might be anything. It can be a gas or it can be a solid. So when it is mixed completely, you cannot see. The solution is clear. It is very clear. So it is when the solute is mixing completely. The mixture of two or more substances is known as a solution, a homogeneous mixture. A homogeneous mixture is nothing but the mixture of two or more solutes in a solvent. Okay. So now a solution has a solvent and a solute, both. Both are there. Solvent is the water and solute is whatever you're mixing in it. So it makes a solution. A solvent forms the major part of the solution, while the solute is added to the solvent. So here the solubility is the property of a solid, liquid or gas. Any chemical substance, or it might be a solid, it might be a liquid or gaseous or any chemical substance, which is called as solute, which is mixing. We are mixing it in the water, which is dissolved completely. It is called as solubility. When it is dissolved completely, it is not visible to us. It is clear. Now water is clear after adding the solute. Now water is clear. It is called as solubility. It is completely dissolved in it. When you're mixing the sugar in the water, can you see? No, because it is completely dissolved. Now the clear solution, it is very clear. Now it is called as solubility. So here, the formation of sugar solution, if you see, it is only a physical change. As the dissolved solute can be recovered. It can be recovered because it is a physical change. Why we are calling it a physical change? When we are mixing salt in the water, when we are mixing sugar in the water, we are calling it as a physical change. Why we are calling it as a physical change? Because they are reversible. They are reversible. Why they are reversible? Can anyone just tell me? Why I'm calling it as a reversible? Why they are reversible? When I'm adding the sugar in the water, when I'm adding salt in the water, They are called as physical. Physically, I'm doing that. It is a physical change. Why am I calling it a physical change? Because they are reversible. Why am calling them as reversible? How can I get them back? How can I get them back? Yes, Tanushree?
Ma'am, after sometimes it gets down, ma'am.
No. How can we have already learned it in the changes of matter. In your previous lesson, changes of matter. You have learned it. You have learned about physical and chemical changes. You have learned about reversible and irreversible, fast and slow changes, isn't it? We have learned it. So how can we say that it is a reversible change? How can we get back? How can we get back the sugar from the water? How can we get back salt from the water? Usually, what is the procedure of getting the salt from the water? What you have to do to get back this sugar and salt? What water have? What the property water has? Yes,
Ma'am, evaporization process.
Ma'am,
yes. By
ma'am,
evaporation. Yes, Hanvita.
water has the property to dissolve anything.
Yes, you told water has a property to dissolve. I'm asking you, just Harsh, what Harsh told me, Harsh gave me the answer that by vaporization process, when we are heating the water, we are evaporating all the water in the form of vapor. Okay. And now, when the water is evaporating completely, what remains when the water is evaporating completely in the form of gas? What remains down? The salt and the sugar, it remains down. So we are getting back the salt, isn't it? We are getting back by evaporating all the water, we are getting back the solute. So this is a reversible change. Understood? So this is a physical change. We are getting back the things. We are getting back the sugar and salt. The dissolved solute we are getting back. Okay? Please mute yourself. So children, here again a stage comes. So here we have seen we can recover this salt and sugar. Now what happens if we are going on adding the sugar into the water or the salt to the water? We are adding 10 spoons of sugar, 10 spoons of salt in the water. Now what happens if you go on adding only a certain amount of salt, a certain amount of sugar, 1 spoon in a little quantity if you're adding, it is dissolving completely. Now, if you go on adding, what happens? What happens if you go on adding? Yes, yes, Harsh.
Ma'am, it will remain down only, ma'am.
Yes, it remains down. So why it is remaining down? It settles down in the solution. Now it settles down. Hanvita, as you told, now if you go on adding lots and lots of amount of solute to the solvent, what happens? Now it settles down. It won't dissolve because these particles of sugar and salt, they get settled inside the small spaces. There are gaps between the molecules of water. So these solute particles, they go and they just sit in those, they try to sit in those spaces, in those molecules, the spaces in between the molecules. Yes, Hanvita?
Ma'am, ma'am, can you tell again, ma'am? I did not understand.
Okay. I'll show you one video so that you can understand it completely. I'll just stop this share here. I'll show you one video. Yes, this is a video. You can see for solubility. You can understand it clearly after watching this video. Please inform me if you are not able to hear it properly.
Have you ever poured sugar into your tea and stirred it up? Why does the sugar seem to disappear? Well, it's actually dissolving, which means it breaks down and becomes absorbed into the tea. And it does so because it has a chemical property called solubility. Solubility is the ability to dissolve into, or become a part of, another substance. Something that dissolves, like the sugar in our example, is called a solute. The substance that it dissolves into, like the tea, is called the solvent. When a solute dissolves into the solvent, the end product is called a solution. Imagine a small crystal of sugar. When it touches water, the tiny water particles.
Yes, one second. Yes, Hanvita, what happened?
Ma'am, it is stucking, ma'am.
Yes, it is stucking. It's because network problem, it is stucking. I hope if the network is very clear, then you can hear it properly, okay?
Okay, ma'am.
Yes, Shikshita.
Ma'am, I can't hear the voice, ma'am.
Okay. Just one
No,
second.
ma'am,
I'll
we
just.
can hear. No, ma'am, we can hear it clearly only, but it is stuck in middle.
Okay. Check your net, Shikshita. I think there will be a problem from your side.
Around that. Have you ever poured sugar into your tea and stirred it up? Why does the sugar seem to disappear? Well, it's actually dissolving, which means it breaks down and becomes absorbed into the tea. And it does so because it has a chemical property called solubility. Solubility is the ability to dissolve into, or become a part of, another substance. Something that dissolves, like the sugar in our example, is called a solute. The substance that it dissolves into, like the tea, is called the solvent. When a solute dissolves into the solvent, the end product is called a solution. Imagine a small crystal of sugar. When it touches water, the tiny water particles surround that sugar crystal and bond with it. It's like the water particles are telling the sugar, "You're in our club now." The sugar still keeps its features, like the sweet taste. But because the sugar's bonds were loose, those bonds have been broken apart by the water particles, and the sugar becomes bonded to the liquid water. Many other solutes